Hello, everyone. I'm Upanshu Singhal, and I'm a distinguished member of technical staff in Dell, Bangalore, India. I'm going to talk about the problem statement Medo Analytics with respect to the predictive analytics on medicines and doctor availability in government hospitals, which we will refer here as primary health care centers. So the problem statement for the predictive analysis talks about the development of a healthcare information system to provide predictive analysis on medicines availability in government hospitals and predictive analysis on increasing the efficiency of the hospitals by managing availability of doctors and hospitals. So some of the things are like improving the clinical effectiveness of patient satisfaction with this application, which translates to improve the clinical quality of care, improve the wellness, prevention, and disease management, and improve the overall operations effectiveness in a public health care center, which could lead to reduce the cost and increase the public health care efficiency. It would increase the operational speed and the adaptability with the system, and also improving the financial and administrative performance, which increases the revenue of a PHC, improves the utilization of resources in terms of the PHC staff, doctors, distribution of medicines, etc. It also helps to reduce the fraud and abuse with respect to the medicines. Sometimes they get sold out in the market with a very low price, and the hospitals run out of the medicines. And also optimize supply chain and human capital management. That so you do the prediction of what all medicines will be required in next week or next month, so that they can be available when they are required without waiting on those. So the use cases are is like the government hospitals provide medicine for the treatment to the patients based on the diagnosis, and these medicines usually are free. The treatments are free in government hospitals, and during the peak time of disease, sometimes some medicines are not available in the hospitals. Based on patients' historical and current data system, this system can generate a report on what all medicines should be available in the hospital and in what quantity at particular time and location of the hospital. So this includes all the demographics of a public health care center, the demographics of the your village or your town or your city, and we can do the predictive analysis on those. Another use case could be for PHC as well as for private healthcare is doctors and specialist availability, which needs to be managed as per the inflow of the patient. So sometimes, patients do not find the required doctor during the peak of disease or shortage of doctors in a hospital. So, for example, there is a dengue breakout, or there is a swine flu breakout, and or there is some natural disaster happens or some accident happens. So you don't find the doctor availability at that time. So based on the patient inflow for a particular ailment or disease, their historical data and current data, the system could generate the requirement of number of doctors required in a hospital on daily basis, and also during a peak of a disease, or sometime during a season. So for example, during the Diwali, there are many patients who come with burn injuries. So that time, some of the specialists or the arrangements of the medicine and all can be arranged in the PHC. Many times, doctors are not available when patients need them more. For example, on weekends, holidays, and evenings as well. So there are the target customers here are like the Indian Government Healthcare Department, where you have the primary healthcare in villages, towns, cities, And this solution will provide solution to analytics to bring in efficiency in operational functioning of the primary health care. And a specific use case under purview of this program are predict medicine availability and predict number of doctors and specialists. This is a simple architecture where we, on the very left side, we have a web-based GUI or a mobile application, and some of the data sources which are coming. And then in the middle, we have a database system. So here the database system green plum is given, which is a very highly scalable database system, but we can use any database management system which is available, like MongoDB or Hadoop or anything. And then there are some data connectors which will be provided to the application on the left side. And once this data is there, there will be algorithm for prediction, description, decision model, statistical algorithm, rule engine, and using the map APIs, R language, and all. And the output will be in the form of a web-based a GUI with having the map. And output would be like a pie chart or a graph chart, which will provide the medicine, the disease information, the doctor availability in terms of week, month, and a quarter. So we'll divide this solution into three parts. One is the augmented, where we have the predictive analysis on notification engine on the GUI, mobile utilities apps, and health monitor overlays. The primary component would be the data extraction and the data analytics. And the core part will be like predictive analytic engine, connecting or communicating with the different stakeholders. For example, the primary health care medical officer or chief medical officer of the district, the district magistrate, or the ministers or the health secretaries in the government. The workflow will be like you open the web-based GUI. GUI shows the map of India, and which mark all the public healthcare centers for which we can display information about on India map. Once you zoom into the map and select a PSC, collect the data from the backend database, apply the analytical algorithm on that, display the medicine requirement in a year, quarter, or a month, and display physician required in a year, quarter, month. Some of the components which needs to be developed are tool to generate the random patient data, so that you can enter the data of a patient in terms of their name, health, gender, their past history, their demographic information, and their family history as well. You need to design a database schema and to design a Google Map-based GUI, which can run on a mobile or on a web. You can use a language like R, which can be used to predict analysis algorithm, but feel free to use any other language as well. And installation package, which can be deployed on any system, and a user guide is like how to use the system. Other technologies you can use for the GUI like HTML5, or you are basically free to use any other tool, whichever you are comfortable with and easy to use. Use Google Map APIs or any other APIs for apps. You would need a high scalable database system, for example, NoSQL, Hadoop, Cassandra, or MongoDB. Language R for prediction algorithm, and maybe JSON for data exchange. The wish list for this system would be the provide search on the GUI, where you can do a search on PHC, district, state, role-based access. Not anyone can use it, so there should be some security in the system so that everybody cannot use it, only some authorized user. For example, the medical officer of the PSC, the chief medical officer, district magistrate, and all. And there will be role-based analytical results. So everybody doesn't want all the data to be seen. So for example, the chief medical officer would like to see a detailed data report, but health secretary would need a Uber level report on the overall state or overall district. And also the display the information with mouse hovering is like when you hover your mouse on the map and you just hover the mouse on a district or on a PSC, the analytical information is displayed with that. Future, this application can be fine-tuned analytical model with wider and larger data sets, expand the analytical features so that prediction is more accurate, and include new uses targeting for healthcare domain like disease prediction, preventive healthcare. So this is all about the problem statement. Thank you.